everyone, and welcome to another episode of Investigation. In today's episode of Investigation, I will go over the x to the x derivative. Before that, obviously, we're going to do another daily problem. So this problem is obviously a use of the extended power rule over here, and this thing 5x squared, I've labeled it for you, the three different functions. So pause the video if you want to try this problem and proceed the video when you're done. And when you first see this problem like this, you might see, wait, I can just simply use the extended power rule. Yes, we're going to use that, but before that, we're going to simplify the function a little bit. So before we do that, we need to simplify the function. It's still 5x squared times the inverse of tangent times log of 21. But the x squared, we can take the squared out. That will be log 21 of x. But the 2 will be the front. So changing that 5 to a 10. So that is our expression. But hold on a little bit. We can see that x squared over here for negative numbers. If we have a number such as like negative 10, that squared would be a positive number. And that fits the domain of logarithmic functions. However, if we take the 2 out, then we would just simply have 2 times log 21 of negative 10. However, negative 10 is not in the domain, so we will realize that if we take it out, we are actually shrinking the domain to positive numbers. But looking at this function, we know that this is symmetric over y-axis, so we're just missing the other portion. And when we are done, we don't want to forget adding that the other portion is also true, basically. And that we can use the extended product rule. So we need to differentiate this first. That will be 20x times this thing. So that will be 20x times this thing. Copy, paste. So 20x times this plus this other middle one, we need to have 10x squared log of 21x, and the derivative with respect of x of inverse tangent of x is x squared plus 1. And we need to add at the end, that is 10x squared times the inverse tangent of x over this log of 21 of x, and that would just simply be ln of 21 times x. And obviously we can cancel this squared out, and this is what we have. But we need to make sure that 0, 0, this thing is also a point, and we did not forget about that. So that is our expression. This is the differentiated result. And let's get into today's topic. Today's topic is going to be x to the x derivative. Want to differentiate x to the x. And you realize you really don't have any tools to differentiate this right now. We've done the any base to the x. We've done any x to the any base, but we haven't done x to the x. And you realize these two actually don't help differentiating x to the x. And we want to have, in some way, to get rid of this x to the x, or get rid of either the exponent, or we want to get rid of the base to, let's say, a constant, so that we can actually differentiate it. What is the best way of doing that? Obviously, that is taking the logarithm. We can get rid of the exponent. And if we set this thing, so if we set f of x, let's just set y is equal to x to the x. If we take the natural log on both sides, and we can get that x out in front. So there'll be x times the ln of x. That's just ln of y. And over here, we can do an implicit differentiation, and we will get the derivative with respect of x of ln of y. That is equal to the derivative with respect of x of ln of x times ln of x. And we need to use the chain rule over here, and that is going to be 1 over y times the derivative with respect of x, the derivative of y with respect of x. And on this side, it will be x. So this thing, we need to use the product rule, x times this thing differentiated, so that's x times 1 over x, plus this thing differentiated, so that's just 1 times ln of x. And obviously this is just equal to 1, and this is the ln of x. And what we have over here is the derivative of y over derivative, the derivative of y with respect of x. And we can move this 1 over y to the other side, so that's just this. And at last we can plug back our y is equal to x to the x. We can get the derivative with respect of y of x. With respect of x is x to the x times 1 plus ln of x. And that is our answer. Well, you can write this y because we just have x to the x. We can write this as the derivative with respect of x to the x. That is the same thing. And we just have this. The real smart move on this differentiation, it doesn't really look hard, but the real smart thing to do over here is to actually find out and take the natural log on both sides. And this is very hard to think of alone, but this is actually a very smart way of differentiating the x to the x, or even x to the x to the x. And you might want to try that. And I will do the answer of this, the derivative of x to the x to the x, in the next episode. So thank you for watching this episode of Interestigation, and I will see you in the next one, where we finally go over second derivative, along with many variations on the notations. But this is a very simple concept, and the next episode will be pretty light on work overall. Goodbye.